Hello, everyone. Thanks for joining, and welcome to another session of our Day One and Beyond series, where we take you through a variety of topics. Our today's session is Intro to Oracle Cloud Operations. So, in this session, we will cover the fundamentals of operations in Oracle Cloud and explore some of the tools available. And yeah, with that, I'm Olivia Ferda. I'm a cloud engineer on the customer enablement team. I'll be taking you through the second portion of today's session. I'm also joined with Dion. So with that, I will hand it over to Dion to introduce himself and get us started.
Awesome. Thank you, Olivia. So, good morning. My name is Dion Locklear, and I am a cloud engineer from the customer enablement team. With me, I do have Olivia Ferda, who will be taking care of our second half of the presentation today. And without further ado, I'm excited to go ahead and get started and present the Oracle Cloud Operations Quick Start. So, what does that mean, and what will we be covering today? So, I'll start with understanding operations and different ways to access OCI. Then we'll move on to discussions on Resource Manager, Ansible, O&M, monitoring, notifications, events, functions, and logging. By the end of this presentation, you should expect to be able to explain the core areas and principles of OCI operations, describe the tools used to manage and deploy resources, define potential use cases for said tools, and then create a stack with Resource Manager for provisioning infrastructure. So, what are cloud operations? Well, before we get into the meat of the subject, it's important that we provide a foundation for Oracle Cloud and its tools for operations. So before diving into cloud operations, let's start with the Oracle Cloud shared responsibility model. The shared responsibility model shows how the level of customer responsibility decreases as more of your resources move to the cloud. So with an on-prem model, the customer is responsible for the entire stack. As they move to IaaS, the cloud provider, in this case Oracle, handles everything up to the virtualization layer. With the PaaS model, Oracle handles everything up to the OS layer and then all the way up to the application layer on SaaS. So there are several types of deployments which you can take advantage of to comply with your regulatory and latency needs: storage, compute, networking, database governance, and etc. All these moving pieces work together in the cloud ecosystem. What we'll focus on today is how we automate these resources, and from there, how we can continually monitor and track these resources with Oracle Cloud Operations. So with that being said, what is Oracle Cloud Operations? The key components of cloud operations are as shown: build, configure, monitor, protect, secure, and govern. With build, you'll utilize Terraform or Resource Manager to build out your infrastructure. Resource Manager is more of Terraform as a service, and it'll help automate the process of provisioning resources and managing the state of those resources. We'll mainly focus on Resource Manager today in my section of this presentation. After we've built out our infrastructure, we'll need to configure it properly. Configuration management is made simple with Ansible. So say you're provisioning a virtual machine, you can use Ansible to manage the OS, the application layer, and all other configurations. Once our resources are configured, you'll need to be able to monitor them, and that's where observability and management comes in. The monitoring service will help us with monitoring metrics, and notifications can keep track and notify us when those metrics reach a specific threshold. Events and functions can further accelerate automation and visibility within our environment as a means of promoting protection of our resources. So say an object storage bucket is created, deleted, or anything else, we can make an event out of that and be notified immediately. Audit can keep track of who did what and when in the tenancy. And lastly, we can govern with IAM and set up policies and grant permissions to users to limit access to resources. So build, configure, monitor, protect, secure, and govern. These are going to be the 6 building blocks that constitute cloud operations. So there are several different ways to access OCI, and the first of which we'll talk about is the OCI console. The console is an intuitive, graphical interface that allows us to create and manage instances, cloud networks, and storage volumes, as well as users and permissions. Next, we have OCI APIs. Now, these are going to be typical REST APIs that use HTTPS requests and responses. We do also utilize several software development kits that are going to be available for easy integration with Oracle Cloud, including APIs uh, and SDKs for Java, Ruby, and Python. The command line interface provides the same core functionality as the console, plus some additional commands. Terraform is going to be infrastructure as code, software that allows us to define infrastructure resources in files that can persist, version, and share. Ansible allows us to automate configuring and provisioning cloud infrastructure, deploying and updating software assets, and orchestrating complex operational processes. And lastly, Resource Manager helps install, configure, and manage resources using the infrastructure as code model. We'll dive into a few of these access methods just a little bit further, starting with the command line interface. The command line interface is a tool used on its own or with the console to complete OCI tasks. The CLI provides the same core functionality as the console, plus some additional features, such as the ability to run scripts and additional commands. Most useful for managerial tasks, the CLI is built on the Python software development kit and runs on Mac, Linux, and Windows. It leverages Python code to make calls to OCI APIs to gain access to specified services via REST APIs using HTTPS requests and responses. So you can use the command line interface's ability to execute scripts to help build out your infrastructure without the need for a tool like Terraform. It's flexible and scalable, and it can be accessed through the console, developer images, PowerShell, and so on. Next, we have OCI REST APIs. So these are typical REST APIs that use HTTPS requests and responses. It can be accessed through a multitude of SDKs to manage a large variety of tasks on OCI. Permissions for API calls are applied by users, and command line interface access can be role-defined in configuration. The CLI will allow for many tasks using REST APIs to be completed and will generally have an easier deployment. Software development kits are sets of software tools and programs that can assist in building and deploying apps that integrate with OCI services. Utilizing SDKs is another way that you can create scripts to complete different tasks, one of which could be automatically and reliably building infrastructure. If you want to contribute to the development of the SDKs, they are all open source and available on GitHub. And the Cloud Shell is a free web-based terminal accessible from the Oracle Cloud Console that is pre-installed with a set of useful tools. By default, each user is provided a 5 GB home directory, which provides consistent and persistent storage for your files and grabs the ability to run under the same permissions that you've already established via the console. Now let's discuss Resource Manager, our Terraform as a service solution built to help you configure and provision your infrastructure with ease. So let's set some context for Resource Manager as it does leverage the infrastructure as code model. Infrastructure as code, or IAC, allows you to easily define what you want your infrastructure to look like by codifying it. So tools like Terraform have the intelligence built in to produce the end state. Because you have to define everything up front using ACL, JSON, your infrastructure is documented before you even deploy it. The ultimate best practice with IAC is to make all changes through IAC. Essentially, do not deploy infrastructure with a tool like Terraform, then go on to make manual changes. If you follow best practice, your architecture definition is updated before it is applied. By leveraging reusable models, improving configuration, it's easy to accelerate the delivery of complete application architectures. Because the configuration is validated and tested, it can be deployed by just about anyone, even an automated bot, with consistent results each time. This is one of the key benefits of IAC. So now that we have some background on the IAC model, let's talk Resource Manager. Resource Manager is a fully managed service that lets you provision and manage infrastructure resources using Terraform. You can bring in your Terraform template definitions and easily create and manage your infrastructure resources. This allows you to use infrastructure as code to automate provisioning resources across all OCI, including compute, networking, storage, and much more. It currently has support for the command line interface, SDKs, as well as the console. Resource Manager does help mitigate a lot of problems that users face while deploying resources on any cloud. You could write your Terraform configuration once using the HashiCorp configuration language and use it to create multiple environments. Resource Manager will save the state securely for you on your object storage and also locks it if multiple members from your team are trying to modify it, preventing any possible corruption and inconsistencies. You can also define permissions for your team through policies and give granular access controls for various Terraform actions like plan, apply, and destroy. Resource Manager is built on open source standards and integrates well with the overall OCI platform, including IAM, tagging, and key management storage, as well as much more. Let's go over Resource Manager key terminology. A stack represents a set of OCI resources that you create in your tenancy, like a database or load balancer. Each stack maps to a configuration and state file, which we'll go over in the demo later. A job performs the actions that are defined in your configuration, like plan, apply, destroy, and import state. So how does it work? Well, to keep it simple, there are three main jobs that you can execute. The first is plan job. Before provisioning anything, you want to review the infrastructure and make any necessary changes. Plan will give you a resource action legend that will let you add and delete resources from the job as needed. Next is apply job, where you'll actually provision resources. From there, it may be a good idea to review your state file, which will have key information about the state of your resources and maps your stack and resources to your configuration. The state file can also be downloaded for later use. Last, if you need to destroy or deprovision the resources that you've created, you can run the destroy job. So these are the three main jobs that we use within Resource Manager. Plan your infrastructure before applying those changes and destroy if needed. Keep in mind that only one job can run on the stack at a time, so you'll need to wait for the job or one job to finish before executing another job. Again, this is to prevent any inconsistencies or corruptions within our data. When working with Resource Manager, all you have to do is make sure that your provider configuration is adjusted to use Resource Manager. That means you can omit the user OCID, private key, fingerprint, and tenancy OCID from your provider configuration. All the rest of your Terraform files will remain the same. And with that, we'll go ahead and move on into the console for a quick demo on Resource Manager. So the first thing that we're going to want to do is access the hamburger menu in the top left. We'll come down to Developer Services, and then we'll go to Resource Manager. So here we have the overview page for Resource Manager, and this is going to be a great way to get started with Resource Manager if you are brand new to the tool or if you just want to stay up to date. So at the top of the screen, as we can see, we do have the option to take a tour around the console to help familiarize ourselves with the tool. Today, I will be that tour. As mentioned earlier, there are multiple ways to create a stack, and a stack is just going to be a collection of Terraform files for the resources that you're looking to provision, whether that's a compute instance, a VCN, or etc. Get started gives us a few ways to create a stack and a little bit more as well. So as we can see, we can create a stack quickly. We can create a private template, a configuration source provider, or a stack from the compartment. Documentation and what's new are going to be good for learning and staying up to date with everything Resource Manager and Terraform. So under the documentation section, we do have an overview, getting started, tutorials, stacks and jobs, templates, as well as continuous integration on continuous delivery. And the what's new section is going to give us everything that we need to make sure that our knowledge is as up to date as possible when it comes to everything Resource Manager, Terraform, and HashiCorp configuration language. Last, there are going to be tutorials on the bottom of the page that will give us a little bit more insights into Terraform, Resource Manager, and everything that kind of goes into that. And we do have more tutorials that we can view here as well. Let's talk about stacks. So when creating a stack, we do have 4 options and another option that I'll go over briefly as well. So the first option is going to be My Configuration, which allows you to upload your own Terraform files and make sure that your provider configure. All you have to do is make sure that your provider configuration is up to date with all of the changes that you want. So you can upload a folder through an object storage bucket or a zip file with My Configuration. Next is going to be template. So there are several Oracle provided templates. We have quick start templates, service-based templates, architecture-based templates, as well as private templates that we can utilize as well. And all of these templates are easily able to be leveraged by a click of a button. All we need to do is select the template of our choice, and from there we can go ahead and use that. Our third option is going to be our source code control system. So if your stack is located in Bitbucket, DevOps, or GitHub, you're able to pull from there. And last, we have creating a stack from an existing compartment. So all we need to do here is select our compartment, our region for resource discovery, and from there we have the option to select either all or selected Terraform provider services. And then from there we can go ahead and select our services. For some reason, it's not letting me do it now. But this is how you create a stack. And I also mentioned that there's another way to create a stack. So anywhere that you're on OCI, you kind of have the ability to save the resource that you're looking to provision as a stack. So say I wanted to quickly create an autonomous database, I'd give it all the necessary information, and at the bottom of the screen, I'd have the option to save the resource configuration as a stack. So I can use this stack to install, configure, and manage resources through Resource Manager Service. And that is going to be the fifth and secret way to kind of create a stack within Resource Manager. But once we have our stack, we can go ahead and view it. As mentioned before, there are going to be three main jobs with our stacks in Resource Manager. We have our plan job, our apply job, and our destroy job. And keep in mind that only one job can run at a time. And again, this is to prevent any inconsistencies or corruptions within our tenancy. If we look at our jobs down here, we'll notice that we have state files for our destroy jobs and our apply jobs. This is because there's no state to view within our plan job, as we're only planning out our resources and not actually executing anything. So if we dive into a plan job a little bit more, actually, we can look at the logs. The first thing that you want to look for when looking through the logs of a job within Resource Manager is that Terraform has been successfully initialized. This means that we can begin working. So if we look at this log for this plan job, we see that it looks like we're creating an autonomous database and the resources that come with it. We can scroll all the way to the bottom to get the summary of this plan job and find that the plan is to add 12 resources, to chain 0, and to destroy 0. We also have the ability to look at the variables here, as well as download our Terraform configuration or our plan. We can even edit the job's name as well. So that's a plan job. Now let's go ahead and look at an apply job. Similarly to a plan job, we're looking for Terraform has been successfully initialized just to verify that our environment and our job have started correctly. If we look here, it seems that we are now applying and provisioning the resources that we planned for previously. And just to validate that, we see that the apply has been completed in our summary. Resources added are 12, chains 0, and destroyed 0. So here we can validate that the resources that we had planned for in our plan job have now been provisioned within our apply job. We also have the ability to view our outputs down here, our variables, our job resources, outputs again, as well as our state. And again, we have the ability to download our Terraform configuration and state, as well as edit the job.
And you can also roll back to a previous version or apply job if you want. So there's an option to do that as well. And you can also run a plan job before actually doing that rollback, but that's something that you can do in the console.
Absolutely. Thank you, Olivia. So within our more actions, we also have the ability to import a state, to download the Terraform state, to move resources, to add tags, or even delete the stack if needed. And the last thing that I want to talk about with Resource Manager is drift detection. So Resource Manager, again, is an automation tool, and you want to make sure that you're making all of the changes through Resource Manager and not the console. If you happen to make any manual changes and then run a job, it will revert back to the previous state. What drift detection reports will help keep track of is changes that were made to resources outside of Resource Manager and in the console. So whether that's full stack or specific resources, we can keep track and see if any inconsistencies may have gone on by doing a job manually instead of within Resource Manager. So once drift detection is enabled on our environment, we have the ability to kind of view the status of that here. And that will go ahead and conclude my demo on Resource Manager. And I'll go ahead and pass the baton to Olivia, who will continue with the presentation.
So this just kind of builds off what Dion was just covering with infrastructure as code. So with the Resource Manager, Terraform, it's going to be a good infrastructure as code provisioning tool, but it doesn't come with that configuration management piece. So that's kind of more of where Ansible comes into play. So it can help with system updates, deploying software, maybe orchestrating advanced workflows to support your application deployment, all of that. And one thing you'll kind of notice on the slide right here is that the syntax will be slightly different. So with here, it's going to be in YAML. Another thing to note too, and you'll see this in the demo shortly, is that with Ansible, it's gonna be more procedural in nature. It's gonna run through a set of defined tasks in your playbook. Just kind of building off too of what it can do. So one use case is around continuous delivery. So this is more stage and test. So your Ansible inventory can be split to separate your environment into different groups of machines. So you can test your plays with the staging machine. And if that test passes, then it can be instantly run against production if you want. Ansible can work with networks, load balancers, and other devices that might need touching during a rolling update. So for example, you can add or move servers from your load balancing pool and disable monitoring alerts for each machine that is being updated. Another area is around orchestration. So if you are managing clustered applications, maybe multiple data centers, public, private, and hybrid clouds, and also applications with complex dependencies, you can orchestrate your complex tasks with Ansible so it can help ensure all these tasks happen in the proper order, that the database is up before the backend server, or that the front-end server is removed from the load balancer before it's upgraded. So those are some of the use cases there. And just briefly before I hop into the console, is that you can use Ansible with OCI. So Oracle provides a number of Ansible modules that you need to install to interact with OCI. And Ansible works by connecting to your nodes and pushing out small programs called Ansible modules to them. And so you can do this in your own terminal if you want, but you need to set up a few things. So you need to install the OCI Python SDK, which would enable you to write code to manage and provide OCI resources. You can also do this in Cloud Shell, which is something that Dion covered earlier. It's nice because it already has the OCI CLI and Ansible set up for you. So we'll see that in the console. So for time purposes, I've already launched Cloud Shell right here. So this is where you can go ahead and do so. And then there's also code editor. So if you want to make changes to your Ansible files or maybe your Terraform files, you can go ahead and do so with code editor right here. So that is an option. And then once you've launched it right here, this is what your Cloud Shell will look like. And so what I've already done is I've installed the OCI Ansible collection. It has a few example playbooks, so we'll take a look at one today. And I'm just going to go ahead and maximize this so it's a little bit easier to see. So I'm going to go into that directory, Ansible collection. And then once again, there's some samples right here. And you can see that there's going to be different playbooks that you can run for some of the different resources. or examples right here. And depending on the playbook that you run, sometimes it can take about 14 minutes, but there actually is a shorter playbook that I can run for networking around creating a VLAN. So I'm going to go into that directory here and then go into create VLAN. And then right here, I can see all the different YAML files right here. So the one that I'm going to be running is this sample YAML file. And if I wanted to make changes to it, one way is using code editor. But I'm just going to go ahead and take a look into the file right here. So once again, syntax is different than Terraform. One thing to note that we modified in the file right here is the prompt for a sample compartment OSID value or Oracle Cloud Identifier. Because depending on the playbook that you run, it might ask for different OSID values. And so we just asked it to prompt for right here because if you try to run the playbook as is, you'll get some errors, or you can just export it manually in the terminal. You have your variables right here, different tasks. So it's going to import the setup, and then at the end, it's going to tear down everything or delete the resources. So it's kind of just written in the playbook right here. But of course, you can make some changes. So that's what that looks like. And then if you want to go ahead and run this playbook, sample.yaml. Once again, this is something that we kind of wrote in to prompt for. Otherwise, once again, you need to export that variable. And yeah, it's very procedural in nature. It's going to run top to bottom through the different defined tasks right here. And then in a moment, because this playbook is fairly short, it's going to start going ahead and deleting some of these resources because it imports the teardown playbook. So we can see that it's deleting the VLAN, deleting the network security group, the route table. And then at the very end, it will give me a play recap. But yeah, I just kind of want to show you what Ansible looks like. Um, Also, another way of creating a stack, and we don't really cover it here, is OKit. So it's more of dragging and dropping to build out the infrastructure that you want to provision. So you can kind of see how it works right here. You know, drag and drop the different resources, define the properties, and then from there you can generate your Terraform or Ansible scripts. Maybe you can leverage that in Resource Manager, but just want to point this out as another option of generating your stack or your resources. So going on to the next piece of our presentation is monitoring in OCI. So let's say I've built out all my resources, maybe with Terraform and or Ansible, and now I want to be able to get a little bit more visibility into those resources or that infrastructure. So in the next few slides, I'm going to cover some of the tools to help you achieve that. So this is a high-level overview of observability and management, or O&M. So today we'll mainly be focusing more on the right-hand side of the slide, so more of the platform services, monitoring, notifications, events, functions, all of that. But we'll also take a look at some of the key management services right here, like logging and the service connector. So you can get an idea of how these different resources work with each other to give you insight into your environment. So first tool that I want to discuss is the monitoring service. So this enables you to perform active and passive monitoring of cloud resources using metric and alarm features. So your different resources in OCI, services like compute, autonomous database, or maybe your application services and resources are all going to continuously emit metrics to the monitoring service for active monitoring. And then alarms are going to use these metrics for passive monitoring. And just to give you an example, so let's say for your autonomous database, you want to know when CPU utilization exceeds 80%. So you can set up that alarm right here for that resource. And then if it does exceed 80%, then you can be notified of that. And then if not, then you won't receive any notifications just because it hasn't reached that threshold. And you can also view these different metrics in the OCI console. There's the OCI SDK, CLI, or API, or maybe some of your different monitoring tools. And that's just one metric example. There's different metrics that you can monitor for your different resources, so it kind of just varies. But just to give you an example there. And this brings me into the notification service. So as we saw, this ties in with the monitoring service. It also ties in with a lot of other services in OCI to keep you up to date. So there's the event service, the service connector, your applications, all of that. And so how this works is you would first create a notification topic. So you really just give it a name. And then from there, you can add your different subscribers. And there's different channels or protocols for that. So you can see kind of a list right here. So email, functions, HTTPS, PagerDuty, Slack. And one thing that you would want to check is making sure that these subscriptions are active. And so you can actually see the state of that. So if it's pending, that might just mean that the subscription hasn't been accepted. So you just want to make sure that it's active. And then once you have your notification topic and all of your subscriptions, you can then tie that in with some of these other services here. And we'll see that in the demo. So yeah, this is the events service. This is also something that the notification service ties into. And there's three main components of the event service. So there's the actual event, and this represents a change in OCI cloud resource, both when initiated by the OCI system or maybe by user action. So in our use case today, this is going to be maybe when an object storage bucket is created or deleted. There's also a rule, which is something that you can define. So once again, if you want to know if the object storage bucket is deleted, updated, created, all of that, you can define that rule. And there's different rules you can define for different resources. That's just kind of one example that I'm using. And then based off that rule, there's different actions that you can define. So you can do functions, notifications, or stream. You can do all three if you want. So if you want to be notified of when, once again, a bucket is created or deleted, all of that, you can set up that notification to stay up to date for the different events impacting your resources. And then there's also functions. This is more of the serverless offering. So it just makes it easy to build cloud native applications by letting developers focus more on writing code than managing infrastructure. So with functions, you would simply write, deploy, and call your function. And you can use it for a variety of different use cases. And one use case that I like to point out is around budgets. So in OCI, you can set a budget on your tenancy, a tag, or a compartment. So let's say you set a budget of $1,000 on a compartment. You can set up optional budget alert rules saying, hey, I want to know when I've reached my budget. So in that case, all Oracle will do once you've reached your budget is notify you like, hey, you've reached your budget. So it's more of a soft budget. But if you want to enforce that budget, this is more of where functions comes into play. There's actually a pre-built function out there called the zero quota limiter, which would help enforce that budget. So that's kind of a use case that I like to point out around functions. But yeah, to get started, you first want to have your notification topic in place. So this falls under developer services And then you can also just type right here, notifications, and it'll pop up. So another way to search for that, but you can go right here to notifications. And one thing you want to do when working in OCI is always make sure that you're working in the correct compartment. So I'm going to navigate to the compartment where I have my topic right here. So first up, you just create your topic, give it a name, description. I've already done that right here. So I'm going to go ahead and click into this topic. And then from here, this is where you can create your different subscriptions. So you can see the ones that we have right here. So yeah, I just want to make sure that they're all active. So once again, if they're pending, it might just mean that the subscription wasn't accepted. So you just want to make sure that it is, because otherwise you will not receive those notifications. In this case, the protocol's all email. You can change that, if you want to do a different protocol. You can see the endpoint right here. And if you need to delete one of these subscriptions, you can. And then if you wanted to create a subscription, it doesn't just have to be email. If you want to do functions, you would specify your function, custom URL. And the nice thing too about each of these different options that you select is it will give you some documentation for it. PagerDuty, if you want to do Slack or SMS. But yeah, that's the first step before you can tie this in with some of the other resources to stay up to date. You have your topic and your active subscriptions. So once you've done that, I'm going to hop into the event service. So this falls under observability and management, or O&M. And then if I go right here, scroll down, I'll see the event service. And this is where I can define my rule. So you give your rule name, description, and depending on the service that you select, there's different events that you can define. So if you select budgets, you'll see the list that you can define right here. So yeah, you can do it for a variety of different resources right here. And our use case today, we're just going to do object storage. So I'll just type right here. And then I can define the different event types. I can even get as granular, as object. So if I want to know when a bucket is created, deleted, all of that, I can pick and choose. I can also add another condition. So if I want to add another event type, or if I want to get more granular, maybe filter based off an attribute, I can select that. And then maybe I want to based off compartment ID, availability domain, compartment name, the resource ID, all of this. Another option too is I can apply this to a particular tag. So if I want to filter that way, I can select my tag and all of that. So if you want to get more granular, you can use attributes and or your tags. So yeah, once you define that right there, you can select the action that you want to take. So in our case, we're just going to do notifications, but I can do streaming and functions as well. And then from there, you just simply select the compartment where you created that notification topic. So I did this in shared services. And then I'd simply select the topic right here. And then whoever is actively subscribed to that topic will receive the notification when that bucket is created or deleted. And then I can go ahead and create that rule. And if you want to change anything later on, I'm going to click into this. I could go ahead and edit my rule. So if I want to change anything, I can do so here. Or simply if I want to see, the event types, attributes, filters, all of that, I can do so here. But yeah, that is notifications, an example of a service that you can tie it into to get a little bit more insight into the different events impacting your resources. Logging service to get a little bit more traceability into your environment. And there's different types of logs as well in OCI to be aware of. So yeah, so whenever you're running your workloads in the cloud, you will have logs generated from every point in the stack. So whether this is infrastructure, database, audit, application on-prem, and the logging service is going to offer you a centralized view of all your different logs. And yeah, there's different types of logs. So we'll mainly take a look at your audit logs. So it's kind of more high level overview, clicks in the console, API calls to your different resources. You also have your service logs. So this is something that you can enable for your different resources like your virtual cloud network, load balancers, all of that. And this might be useful to have enabled for, let's say, your load balancer, because for your load balancer, there's two different types of log groups, which are your error log group and your access logs. And let's say one of your backend servers is down or something's wrong with the service or going wrong, that's going to end up in the error log group. And so it would be useful to have all those different logs. And I'll also show you as well if you want to be notified of any particular error, you can set that up, and that kind of ties back in with our notification service. You also have your custom logs. This is more for on-prem, your applications, all of that. So those are different types of logs to be aware of. And then just kind of building off of your audit logs. Once again, this records all API calls to OCI resources. These records are key for any security and compliance reasons. So with audit logs, you can see what activity occurred, who initiated it, time of the request, so stuff like that. And you can get activity from different sources like the console, SDK, and CLI calls, since they all go through our APIs, just to give you a little bit more traceability and visibility into your infrastructure. All right, so now that we have an introduction to, all right, so this is gonna fall under observability and management. This is also where the event service is as well. So real quick, I'm just gonna go into our audit logs right here. And yeah, this is more of API calls to your resources, clicks in the console, stuff like that. So right now it's just looking in our shared services compartment. If you want to change that, you can go ahead and do so. You can also filter through these different logs based off user, and it's going to populate with any, recent users like myself. Resources, you can filter this way. So I was recently in notifications and the events rules. There's also request action types, so like get, post, put, patch, delete. You also have the event type, so like getting the rules, listing the rules, all of that. You have any custom filters, so maybe keyword. And right now, it's just filtering logs based off the past 5 minutes. I can do past hour, past 3 hours, I can do today. You can also do custom, but there can be no more than 2 weeks between the start and end date for that search. Otherwise, you'll get an error. And yeah, this is what these logs look like. So you can see the event time, the user, the resource, the action, the type, and then you can expand this to get a little bit more details. So these are your audit logs and kind of what that will look like. So yeah, so going into logs right here to take a look at some of the other log types. So we won't really explore custom logs today, but I just want you to be aware you can use this more for like on-prem, custom applications, other cloud providers, stuff like that. You also have your service logs, and I'm just going to make sure I'm in the correct compartments. So I'm going to go to infrastructure because we have some examples right here. So you can enable your service logs, and depending on the resource that you create, you also see this in the console as well, because when you create, for instance, your load balancer, at the very end, it'll give you an option to enable those logs, but you can do so right here. So you select the compartment and the service, and you can see a list right here. So let's say load balancer, select the resource, the log category, because for load balancer, there's access and error logs. They'll kind of vary depending on, the resource that you select. And then you can enable it. You can also enable auto archiving to object storage. So you'll see here under advanced options, for log retention, you can do 6 months, but if you want to keep it longer than that, that's kind of what that option is referring to. So you can set the log retention time right here. So one thing to note right there. And we've already enabled the load balancer error logs right here. So I'm going to go ahead and click into that. And this is just looking at past 5 minutes. So there might not be anything. So let's see today, there might be something. And so yeah, you can see that there's an error right here, the time. You can copy this message right here to get a little bit more insight. And then you can also expand it. So yeah, you can filter by time. You can do custom right here. And then there's also something called log search if you want to get a little bit more granular with your search. There's some custom filters, so like date time, error type, equal to, not equal to, or something. If you have some saved searches, you can just select that right here. There's some quick start queries right here. So kind of depending on what you're searching, you can, make a query right here to modify that. So that's kind of more of the advanced mode. You can also visualize this as well. So you can see, you can do stack bar, you can do pie chart, all of this right here. And I also want to show this page because let's say you want to be notified around some of the different logs that end up in that service log. What you can do is click create connector, or you can do it right here. So that is the service connector tool. So if you click that, it'll launch the page for you. So you give it a name, description, and then, which compartment you're creating that resource. So in this case, you can use the connector for a variety of different use cases. But right here, we're just going to be sifting through the different logs in that load balancer error log group. So my source would be logging. And then depending on your use case, you can select your target right here, but we want to be notified. So I would select notifications. Then from there, I would select my log group where I want to search. So I want to search in that error log group right here. So right here is pretty important. So if you do not define anything for your log filter, you will receive notifications for anything that ends up in that error log group. If you want that, that's fine. If not, this is where you can define certain properties. If there's something in particular that you want to focus on, you can define that right here. So let's say request, you can define the operator, so equal to, not equal to, and a certain value. You can add more filters right here, like user agent, all of that. So it allows you to get a little bit more granular if there's a particular error that you want to narrow down on. And then from there, this is where notifications is pretty important because you would tie this back into a topic right here, and whoever's actively subscribed would receive that notification. Right, so those are your logs. Just to recap, so you can use notifications and events to be aware of the different events impacting your resources. You can also use notifications to tie in with some of the other services like monitoring and the service connector, as we just saw. You can use a resource manager to help automate the process of provisioning your infrastructure. And then There's also O&M or observability management to give you a little bit more insight into your environment. And once again, you can use notifications to tie into other services to keep you up to date. These are some of the other ways of learning more. There's Oracle University, different certifications or learning paths. One thing that I highly recommend is live labs, so getting more hands-on experience with some of the different services in OCI. And then there's some documentation right here. All right, so right now I'll pass it over to you to go over customer enablement and Code Innovate.
Thank you, Olivia. Hello, everyone. What you see right now on the screen are 4 enablement options. This session that we're doing right now falls under the third category, which is the Day 1 and Beyond session or webinar. But if you would like us to conduct a similar session just for your organization at no extra cost to you, then do email us at our personal training email and we'll reach out to you. You see that email right at the bottom, personaltrainers_us@oracle.com. If you want us to conduct just a hands-on lab, we have our newly designed QuickShot Live Labs for an expedited hands-on learning towards a particular topic. So again, you use the same email address for that. Under the Code Innovate program, we'll work with your team and co-develop a solution with you based on your use case. So it takes about a week, half days, 5 half days. So remember that anything on this slide is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. So any questions, do email us at these email addresses and we will get back to you. So Olivia, if you can put those email addresses in the chat. And we can move on to the next screen. And here are the other Day 1 and Beyond series that we are doing. We recently added the Analytics Cloud series. So if you go to the Day 1 and Beyond page, the same page that you used to register for this session, you'll find the new series there, right on the top of the page. So I would suggest that you bookmark that page and do visit all these series for any new sessions that we are adding on trending topics or anything that is more popular or more requested by our customers. So thank you so much for joining us.
And yeah, thanks everyone for joining.
Thank you again for attending today.